check everything. Looks like I'm live. Okay then. Even looks like there's maybe one other person besides me. Hello, one person. Today we're talking about mammals! You're so happy to be a mammal, aren't you? Yes, mammals. Do you want Yeah, you damn cat, turning things off. Okay, I'll let you go away now. Let's talk about mammals. What is a mammal? The different types of mammals, and the evolution of arguably one of the most successful slash destructive mammals there is, the human. So away we go. We are now all the way down in the phylogeny of deuterostomes here at the very end of the amniotes with Mammalia. Right? There are some important features of mammals. Right? There are four, well, major features. They include the mammary glands. This is, why they are named mammals. So the glands for which the name derives, the mammary glands. The mammary glands secrete milk. Milk being the nutrients that support the infant mammals, right? Mammals are endotherms. At some point in their life, all mammals have hair, or even the ones that don't have hair generally have either embryonic whiskers of some sort or just are from a lineage with a secondary loss of hair. They have the four-chambered heart, just like dinosaurs. A particularly useful development is the muscular diaphragm. If you watched the thing on reptiles, you know reptiles don't get a diaphragm. So, we have a larger brain, which we share with the dinosaurs. That's sort of a hallmark between mammals and dinosaurs. The most complex tool-using animal on Earth besides the human is a New Caledonia crow, a dinosaur. So that's kind of cool. And comparatively, and compared to most other amniotes, we have extended parental care. A lot of that sweet, sweet K selection going on. And then, as we'll talk about shortly here, if you want to know if a fossil is something related to mammals or reptiles, look for differentiated teeth. What does it mean to have differentiated teeth? Well, when you go to the dentist, they talk about your molars, right? Then they talk about your premolars, whatever. I'm not going to even draw in the right number. Your canines, your front teeth, and so on. Right? These are teeth for chewing and grinding. Your premolars do a pretty good job of grinding and cutting. Your front teeth do an efficient job of slicing. You can slice up small pieces of food off of something with your front teeth. And then your canines are your pointy grabbers. That is, of course, the official scientific term for the function of the canine, the pointy grabber. So you will notice all these teeth are quite different from one another, having different shapes and different functions. Those different morphological teeth are why we refer to them as differentiated, or mammals have heterodont dentition. Heterodont dentition. We can contrast this with reptiles that have homodont dentition. While they may have teeth that are different in size or how long they've grown in their mouth, the teeth will not have any morphological differences from each other. They will just all be identical. So, homodont dentition is seen in reptiles and dinosaurs. So that's pretty fascinating. Mammal evolution is fascinating. Mammals come from a line of animals called synapsids. Reptiles are part of a line of animals called diapsids. The difference between a synapsid and a diapsid has to do with some holes in the skull. The diapsids have, I think it's two preorbital fenestra. So you have your orbit and then you have some holes. So this is where your eyeball would go on the skull. And then that skull has two preorbital fenestra, holes in it. So you can see this in dinosaur and reptile and bird skulls, those preorbital fenestra. Makes them a diapsid, right? Whereas synapsids have fused, their skulls are fused. So if you look at the skull, there's no preorbital fenestra fused over. So diapsids are homodont dentition. Synapsids are heterodont dentition. These are our sort of fundamental lineage branch features. So when you look at the evolution of mammals, you can find the initial division between synapsids and diapsids way back in the Triassic with the mammal-like reptiles. If you've ever seen this particular animal before, you might know it as the Dimetrodon, or Dimetrodon if you say things weird because you're not saying it the way I say it. The Dimetrodon is indeed a synapsid. It is much more closely related to a mammal than it is to a dinosaur. So if you ask someone what's your favorite dinosaur and they say the Pteranodon and you slap them in the face because they're wrong, and then you say, no, you moron, your favorite dinosaur. And they say, fine, then I like the Mosasaurus. And you punch them in the gut or the kidney because they're just not being correct. And then you say, what is your favorite dinosaur? And they say Dimetrodon. And then you, I don't know, like, just go nuts and dislocate their arms and throw them in a river because they were wrong about something technically. I guess I'm getting over passionate about this. Anyway, the Dimetrodon, I find it just amazing that the Dimetrodon is indeed a synapsid, a mammal-like reptile, and that even though it has these cool features like osteoderms and scales that make it closely related, that has the intermediate reptile features, it also has a degree of heterodont dentition. So the Dimetrodon has the synapsid skull, and it also has heterodont dentition. So that makes the Dimetrodon really cool. All right. Genuine mammals appear in the fossil record somewhere around 200 million years ago. So they evolved around the same time dinosaurs were getting popular. And since dinosaurs were so successful and adaptively radiated to occupy nearly every niche you can think of, mammals were not exactly an incredibly diverse or class. They were largely rodent like. They were relatively small for the era. The largest fossils from the appearance of mammals we see are around 1 meter long, or for those of you who are imperialist pig dog measuring systems, 3.3 feet. Uh, and they were not nearly as numerous as the dinosaurs. They basically just tried to occupy niches that dinosaurs didn't. They were largely nocturnal based on the size of their eyes. Um, so, nocturnal burrowing animals that basically just didn't have to compete with dinosaurs or competed with dinosaurs as little as possible since dinosaurs were just kind of everywhere. And very easy for dinosaurs to kill and eat a soft, fleshy mammal. So, when did mammals experience dizzying amounts of adaptive radiation? About the same time that dinosaurs kind of went almost entirely extinct. So, somewhere around 65 million years ago, we had the KT event, which was just a giant meteor slamming in to the Earth somewhere around the modern day Yucatan Peninsula. And it ejected significant amounts of dirt into the atmosphere, cooled things off. The impact itself probably triggered volcanoes. It was just in general the apocalypse. And the dinosaurs, within a couple million years, were all the non-avian dinosaurs in a couple million years were extinct. And sometime around 75 to 80 million years ago, the fossil record shows mammal adaptive radiation. It's not like a meteor hit and the mammals immediately took off, right? Kind of everything had a bad time for a while after the meteor. So, 75 to 80 million years ago, mammal adaptive radiation took off. Between that 65 million years ago and the 75 to 80 million years ago, you actually see quite a bit of avian dinosaur adaptive radiation, which is pretty cool. So, let's talk about those characteristics of the mammals in more detail, starting with hair. All mammals have hair to some degree. Uh, Whether it's secondary loss or just present during embryonic development, they all have hair. Hair serves a number of important functions. If your hair is dense enough, you call it fur, and fur provides insulation in the cold. Hair is pigmented and allows for cryptic coloration, camouflage, so you can hide from predators or prey. So, prey can hide from a predator, and a predator that's an ambush hunter can hide from its prey. Right? Hair can also serve sensory functions. Anybody happen to know the sensory functions of hair? What could possibly be sensory about hair? I don't know. Maybe it's here. Oh, yes, I know. I know. I know. It's so shameful. Every time I mess with you, my mic gets turned off. Go away. Whiskers! Whiskers are a specialized sensory structure. And then, of course, hair can function in defense, right? Porcupine quills. Those are an awesome function, defensive function of hair. Believe it or not, the armadillo armor is keratinized and probably has a derivation from hair. So, porcupine quills, hollow, extremely pointy, and hurty, as the scientists define it. So, hair is a novel feature. It is a synapomorphy of mammals. So, only the mammals have hair. Okay, mammary glands. I just hit this one. These are specialized glands that secrete milk, and those provide nutrients for the offspring. Right? Uh, Most commonly, the milk is secreted from specialized structure, nipples, but not all mammals have nipples. And I'll hit the exception shortly. Of course, we are endothermic with a four-chambered heart and a muscular diaphragm for breathing. So that diaphragm is a pretty amazing adaptation. Helps us breathe with extreme efficiency. It also separates the chest cavity from the abdominal cavity. The diaphragm is a giant muscle. It creates a separation, which, I mean, isn't particularly amazing, but it's cool. And then, of course, as I just mentioned, heterodont dentition. Teeth specialized for different functions. You got molars for grinding, premolars for pointy, slicey, but also chewing, canines, which are your pointy grabbers, and incisors, which are your slissy slicers. Whereas reptiles, right, there may be different sizes in the teeth, but all those teeth have an identical morphology. The teeth are homodont dentition. So, heterodont dentition, molars, canines, incisors, often specialized for the type of food the animal gets. Of course, my mic is falling out, so give me a second to very carefully put that back in there. Okay. So, dentition. Uh, I have a gray fox jaw here. So, this is the jaw, the mandible of a gray fox. You can see that it's pretty specialized for carnivory. The molars themselves have cutting surfaces. So you have very small molars for grinding, and you have much larger molars with cutting surfaces because the gray fox is primarily a carnivore. Gray foxes are particularly cool because they can rotate their forearms, right? Most dogs, they cannot pronate their arms, right? This is how their feet go. Can't do that. Right? Canines cannot do this. The gray fox can rotate its radius around its ulna and move its arms like this. And that allows them to hug trees, and they're pretty much the only fox that climbs trees. There's actually a single breed of dog that can climb trees in a similar fashion. I'm forgetting the name. It might be like the Catahoula leopard dog, but whether or not it can truly pronate and supinate its wrists, I don't know. But anyway, by the way, dinosaurs could not rotate their wrists either. So whereas dogs, are restricted to feet like this, right? Dinosaurs are restricted to this. So if you were ever a kid playing around as a T-Rex going, nah, 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 you were wrong. Wrong. You were a bad person, and you should be ashamed of yourself because a T-Rex could only do this. Rah, 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 rah. So, the next time you see a child playing dinosaur and doing that, I recommend you go to their parents and criticize them for being bad parents. Okay, there are three basic lineages of mammals. Monotremes, of which there are only a few species, are the most basal of the mammals. Then you have the marsupials, and then much more diverse, the most diverse of all the mammals, are the placental mammals. So, eutherians are placental mammals. So, marsupials, of course, are pouched mammals, and monotremes are the wacky ones because they are egg laying mammals. They produce an external amniotic egg. So let's take a look at them. There is, of course, your gold star example of the monotreme, the duck-billed platypus. And then we also have 4 different species of spiny echidnas. I know a lot about duck-billed platypuses, not a ton about spiny echidnas, except that they have a 4-lobed penis, which is mostly terrifying to look at. So if you want to take a peek at that, I encourage you to do so. Okay, the duck-billed platypus is really cool because when the naturalist who first went to Australia and described it brought back the reports, he was unaware that there had recently been a scandal with a naturalist going to South America. Naturalists who could discover and describe species were minor celebrities in their fields. And this one naturalist went to South America and also happened to have had a pretty good career as a taxidermist. And while he was in South America, he went ahead and sewed a bunch of different animals together in order to create a significant number of different species, which is kind of wacky. I think it's pretty cool. Kind of fraudulent. I don't know if there are any fake species left from that era, but the English naturalists were kind of pissed off about it and extremely suspicious. And then this guy comes in from Australia and says, hey, let me describe this species to you. It's got a squat body like a beaver. It's got webbed feet. It's got a long tail, kind of like a muskrat. It's got a bill like a duck. And the males have spurs on their ankles that can inject venom. And they said, ha ha ha, get the hell out. And he brought back a taxidermy example, and they said, ha ha, go away. And it wasn't until he managed to bring back a live platypus that the English naturalists would actually acknowledge it as a real animal. So, the big thing about the monotremes is that of all the mammals, they are the most closely related to reptiles. While still showing the mammalian characteristics. So, their reptilian features. They lay an external amniotic egg. If you look at the anatomy of their amniotic egg, it is pretty consistent with the anatomy of a reptile egg. They have a cloaca, right? Reptiles and dinosaurs have a cloaca. It is a single hole which serves multiple duties. That cloaca is the opening to both the urinary and digestive system, so peeing and pooping, and also the single opening to the reproductive system, sexing and birthing. So, the monotremes are the only mammals that have a cloaca, the common hole, let's call it a pore, because that sounds better than hole. So a common pore for access to the digestive and urinary system as well as the reproductive system. So, none of the other mammals have a cloaca. And then lastly, when looking at the anatomy of their bones, you actually see quite a bit of similarities between monotreme bones and reptile bones. For instance, in monotremes, they have a reptilian sternum. So, what does that mean? That means that the sternum is two bones with a honest to goodness joint in them. Humans have three fused sections to the sternum, and also the clavicle, the collarbone there, is part of the sternum. Is part of the sternum. Yeah. So, a sternum that is jointed and is serves the function of the sternum and the clavicle. They also have some pelvic similarities. So, worth looking at. We have the monotreme sternum here. So you can see there's the joint with two distinct bones and the clavicular extensions. And here's the basal reptile sternum with the clavicular extensions, right? And compared to a mammal, a marsupial and placental sternum, which is a fused piece, but the clavicle is jointed with the sternum. So, the clavicle has a joint with the sternum. In addition, when you look at the scapula of a monotreme and the pelvis, it closely resembles that of a reptile. Do you have to point out this stuff exactly, memorizing the bone structure and identifying the similarities? No. No, I don't think I'm going to test you specifically on the fact that they have a sternum with clavicular extensions like a reptile, whereas a mammal has a jointed clavicle to its sternum, with the bones being separate. But it is pretty convincing evidence that monotremes are the extant animals that are closest to the reptilian ancestors. So, monotremes are basal mammals. Wow, that is amazing. Okay, finally. Basal mammals. So, they are the most closely related to reptiles. So, to the early synapsids, reptiles. You can only find them restricted to Australia and Tasmania. They are generally not very competitive with the other mammal groups. So they are restricted to specific niches. Let's see. The echidna has super weird joints, by the way. Their front feet face forward, and their back feet sort of stick out to the side and backwards. So there's between the four-lobed penis and the strange feet, spiny echidnas are just wacky. Uh, it's just really cool. Look up videos on monotremes. They like the fact that they lay eggs. Oh, the other cool thing about monotremes would be the fact that they are indeed milk producing mammals. They have hair, they produce milk, but they do not have nipples. Monotremes do not have nipples. See, I don't want to put that on the bones, it'll get weird. So instead of nipples, monotremes secrete milk onto the skin. So they have some specialized milk glands that will secrete the milk directly onto the skin. And so it's this area of the skin where the young will lick the sort of milk sweat off their mother in order to feed. So while they do have milk glands producing milk, the milk secretes directly onto the skin rather than having a specialized structure, the nipple, to distribute the milk. So lots of very cool features making it a basal mammal, but at the same time an awesome mammal. On to the marsupial mammals. Looks like I'm still the only one here. Sad panda. Confirm my sound is still working. Yay! Continuing. The marsupial mammals. So, we call these the pouched mammals. The reason we call them the pouched mammals is because they, amazingly enough, have a pouch, right? So it's generally an abdominal pouch. So it's over on the abdominal part of the body below the rib cage. And the abdominal pouch is the site of really embryonic and juvenile development. It's amazing just how early these animals give birth. So when you look, they have a uterus and a vaginal canal, and internal fertilization takes place, right? All amniotes have internal fertilization because they're terrestrial. You can't exactly shoot your gametes at each other through the air and hope that you're going to fertilize something. So all amniotes have internal fertilization. And in the marsupials, fertilization occurs in the oviducts, and then the zygote enters the uterus and starts to develop. Now, interesting things about it is that the embryo has a yolk. An honest to goodness yolk. There's also a chorion surrounding the embryo for gas exchange. So while we don't have a a shell anymore, there's no more shell. We have membranes that you can find in the egg. So there's also the development of a very simple placenta that the embryo will implant into. However, the placenta is simple. What does that mean? It doesn't do much in the way of gas exchange, so it doesn't help with gas exchange. And it does not exchange nutrients. It's more like just a structure to hold the embryo in place in the uterus while it develops. So it's very simple and it's very short lived. The placenta goes away pretty quickly because the really, we should call it an embryo, is birthed on average around 8 days after uh, the egg is fertilized. So, embryonic development happens in the uterus for about 8 days. And then you give birth really to something we should probably call an embryo. If this were in a human, this would definitely be an embryo. You see, there's no hind limbs, there's buds. The forelimbs, while somewhat well developed, don't have separation between the fingers, the digits. Uh, we are very thin skinned, right? The skin only make the epidermis is very thin. The eyes are highly undeveloped and covered in skin, so this is a blind embryo. And the embryo must crawl from the vagina through the mother's fur into the pouch. Inside the pouch is where the mother's nipples are. And the embryo will attach to a nipple and will actually grow a layer of skin fusing the embryo to the nipple. And so embryonic development continues through to infant and juvenile development in the pouch. So, this is a really fascinating system, reproductive system here, because we're birthed so early and everything else happens in the pouch. The marsupials came onto the scene much earlier than the eutherian, the placental mammals. So they evolved about 100 million years ago. So the eutherians evolved much later. So the marsupials first appeared in the fossil record around 100 million years ago. Eutherians later on. So particularly cool. There's quite a bit of convergence between marsupial mammals and eutherian mammals. So convergent evolution is quite visible. This is because the marsupial mammals are pretty much almost entirely restricted to Australia and Tasmania. There are no marsupial mammals in New Zealand because there are no native land mammals, terrestrial mammals in New Zealand. The only mammal native to New Zealand is bats, are bats. So, Australia and Tasmania is pretty much where nearly all marsupials are restricted. There are a few marsupials outside. The opossum is likely one of the most successful marsupial mammals. The opossum is a very cool animal. You can find opossums in North America, South America, Europe. They're all over the place. And they are indeed a marsupial mammal. They have adorable little babies that are birthed early and develop in a pouch. And then after they're old enough, they'll exit the pouch and hang on to their mother's back. Um, Opossums are cool. They are voracious feeders of pests. They will eat the crap out of ticks. So they eat pests like ticks. So they're serving a function for humans. That's good. They get about as aggressive as playing dead and hoping you don't eat them. That is their primary defensive mechanism, is to fall over, play dead, and secrete some foul smells from some specialized glands. so that they also smell dead. Opossums also have a relatively low body temp. Why do I bring this up? Well, rabies, the rabies virus, people sometimes say opossums can carry rabies. Rabies virus is really specialized for placentals. The reason for this is the rabies virus requires a relatively warm body temperature. In general, opossums have a body temperature too low for the rabies virus to colonize and infect them. So, you don't have to worry about an opossum being a reservoir for the rabies virus. The opossum eats pests that can bother you and carry harmful diseases. And the opossums are not particularly aggressive in any way. They'd much rather run or play dead than bite you. So, leave them be. Appreciate your neighborhood possums. Opossums. By the way, possum is in fact a separate species of marsupial in Australia. So make sure to pronounce that O in opossum. Convergent evolution. Since Australia has a lot of similar habitats to places where you see mammals, placental mammals, you can identify a lot of convergent evolution where selective pressures are similar. This is the gray wolf. It is a predator adapted for chasing prey and taking the prey, like hunting in packs and taking the prey. And this is the extinct Tasmanian tiger. They called it the Tasmanian tiger because of the stripes. Some people called it the Tasmanian wolf. Either way, you can see some convergent features. There's a tail. It's actually longer in the Tasmanian tiger because it serves some important balancing functions. It has relatively long legs, although they're a little shorter compared to the gray wolf. And it's really in skull morphology where you see that distinct convergence. So you can see we have pointy grabbers that are extremely well developed in gray wolves in order to grasp and take down prey, and also present in the Tasmanian tiger. We have premolars that are well adapted for slicing, same in the Tasmanian tiger, and we have actually a little bit more well-developed molars in gray wolves because they will occasionally supplement their diet with fruits, berries, and the such that needs grinding. Tasmanian tigers have some molars that are good for slicing and smaller molars. The Tasmanian tiger is indeed extinct. This is a shame. It is not extinct because selective pressures changed. It is extinct because humans are dicks. So important notes about the Tasmanian tiger. It is quite a gracile animal. It has a thinner mandible than a gray wolf. It is shorter to the shorter to the ground than a gray wolf. More well adapted for jumping based on the length of the tail and the legs. And in general, anatomy of the Tasmanian tiger shows that it did not prey on large animals. Unfortunately, it had a passing resemblance to wolves. And so, when the sheep herding and cattle herding, or when the sheep herding industry and cattle ranching industries exploded in Australia, the white folks came in and said, hey, that kind of looks like something that kills sheep, and just hunted them all into extinction. So, Hooray, humanity! They weren't even a threat, but they looked kind of like something that was sometimes a threat on a different continent, and we drove them extinct. White people. Okay, more examples of convergent evolution. We have rodents and marsupial mice. We have the role of burrowing, and you can compare the adaptations of a mole to a marsupial mole, similar enlarged front feet, uh, tiny to blind eyes, enlarged claws for digging. The flying squirrel, which has a membrane between the legs in order to glide, and the sugar glider, which has the same thing. Woodchucks and wombats eating on various tubers and such, Tasmanian devils, small omnivorous predators that are squat bodied and vicious compared to the wolverines in North America, and then kangaroos, which have a relatively similar anatomy to the Patagonian cavy, which is kind of cool. So if you want to look at pictures of Patagonian cavies, they certainly don't look like something that should be living in South America. Marsupials, by the way, originated in what would become South America. So I'm going to put South America in quotes because it certainly wasn't the continent of South America. It was part of a fused continent. So um, they originated originally in South America. They are little tiny, they were tiny, tiny little nocturnal creatures. And there's actually one extant basal marsupial still living in South America. It's extremely cute. It's the little Monito del Montes, the little monkey of the mountains. And it is, in fact, a microtherian marsupial. Microthere indicating that it is part of the lineage that was those teeny tiny little mammals. So, South America, when the continental plates started drifting and South America separated from Australia, you isolated mammals to Australia and what would become Tasmania. The marsupial mammals got isolated there. Whereas in the Americas and Europe, you had the rise of the much uh, more competitive, well, at least the mammals that outcompeted the marsupials and basically drove them extinct anywhere they were, the placental mammals. So the eutherians are the placental mammals. The placental mammals are the most diverse of all the mammals, and they are also the most numerous of all the mammals. So we have a large amount of diversity in placental mammals, and they are arguably more successful than their brethren based on both the number of species and the number of individuals. The hallmark of the placental mammal is indeed the placenta. So, the developing embryo uh, implants into the uterine lining, and that is where it receives all its gas exchange. So you can still see some of the original membranes of the external amniotic egg. We have the chorion, which was once for gas exchange. It no longer really serves a gas exchange function. It's just sort of a membranous layer surrounding the embryo. The amnion is still present, And it still serves the main function of surrounding the embryo in fluid. So the amnion surrounds the embryo in the amniotic fluid, and it still serves the purpose of mitigating gravity during embryonic development. So it's easier for the different features to develop without the embryo being sort of flattened against the ground and having the entire back of it be flat. Anyway, it serves to mitigate the effects of gravity. You even have a tiny little reduced yolk sac. However, it no longer serves to provide nutrients. So the yolk sac is basically more vestigial than anything else. We also only see the allantois as part of the umbilical cord. So the yolk sac and the allantois are now reduced. They're highly reduced, and they are a part of the umbilical cord. So they don't really serve their original function anymore, providing nutrients or storing metabolic waste. And the reason they are not serving their important function anymore, and neither is the chorion serving as gas exchange anymore, is simply because we have a placenta. So if you look at a developing embryo, right, there's my lazy picture. So again, we'll like that. Put a little limb bud there, limb bud there. Okay. So connected to the embryo is the umbilical cord. And inside the umbilical cord, we have the membranes that were highly reduced, but we also have fetal blood supply. This is again, a conceptual drawing, not a proper anatomical drawing. So, what we have for the fetus is this tissue that attaches to the uterine lining. So, here's our fetal blood supply, and it attaches to these little uh, tendrils, kind of look like some foreign creature trying to grow into the tissue. Oh, a scary parasite, right? And these little tendrils implant into the placenta derived from the uterine lining of the mother. Right? So the placenta comes into contact with this tissue. We have implantation, which holds it in place, and the blood from the uterine wall, we develop vascular tissue into this lining. And basically, what happens is the maternal blood supply, because of the way we implant, is so close to the fetal blood supply that we can have diffusion. Diffusion between the maternal blood and the fetal blood. They don't actually exchange blood. Rather, they exchange gases. So they do gas exchange, right? Oxygenated blood from the mother delivers oxygen to the fetal blood. Carbon dioxide, deoxygenated blood, carbon dioxide rich deoxygenated blood from the fetus delivers carbon dioxide to the maternal blood so that the female can exhale both her own carbon dioxide and the fetal carbon dioxide. So there's gas exchange across the placenta. There's nutrient exchange across the placenta. Nutrients from the maternal blood, like sugar and various other macromolecules, can diffuse across the placenta into the fetal blood and provide the fetus with a nutrient supply. And there's waste exchange, where metabolic wastes from the fetus diffuse out of the fetal blood across the placenta, and the maternal blood sends that to the liver and the kidneys to be processed. So we don't need an allantois because we have a placenta. The Carian doesn't do gas exchange anymore because we have a placenta. The yolk is highly reduced because we have a placenta, right? So the entirety of embryonic development occurs in the uterus. So this is a huge, important feature. This allows the placental to um, give birth to a relatively well-developed offspring, right? These offspring are often capable of their own locomotion relatively quickly. Horse colts, the baby horses when born, are able to run within I think an hour or 15 minutes, whatever it is. Um, so guinea pigs, their young are born with all their fur and their eyes open and able to run around. Generally, the more specialized a mammal is to give birth to more young, the less developed those young are. For instance, uh, mice and rats give birth to significant number of babies. They can give birth to like 6 to 10 offspring at once, but they're naked, hairless, kind of helpless, and blind. But they develop relatively quickly, feeding off the mother's milk. That's going off track there. Anybody here? Hello? One other person. Hello, one other person. Okay. So, the placenta is a huge development. It provides these mammals a competitive edge, such that basically everywhere that we had niche overlap, the placentals outcompeted the marsupials. In all but a few cases, marsupials quickly went extinct anywhere that there were placentals. Good old competitive exclusion. So that's pretty neat. Bad for the prehistoric marsupials, but still pretty cool. 17 out of the 19 orders of mammals are placentals. So, just to give you an idea of just how diverse and successful these are. So we got a nice little comparison. This is the standard reptilian and a dinosaurian amniotic egg, a large, well-developed yolk, a large, well-developed allantois, a carion near the shell's surface for gas exchange, and an amnion that is pretty close around the embryo, and it has to be because we need to make space for the other membranes. And here's a monotreme egg. And we can see the shell, the carion, right? We have our embryo. This is a more conceptual map. A amnion very close to the embryo. A large nutritive yolk. Allantois is a little bit reduced, so it's not quite identical to a reptilian or dinosaurian egg. Here's your marsupial. So the portion of embryonic development that occurs inside the uterus we can actually see a relatively large, well-developed yolk, right? We have a slightly larger amniotic cavity there with the amnion. Our allantois is present and functional, but even further reduced. And the chorion is surrounding it, but at the same time, not really functioning that well for gas exchange. You have a relatively simple placenta that grows from this and basically is purely for attachment into the uterus so that this doesn't fall out. Uh, and then you get full on placental mammal, where you have the umbilical cord with its rich blood supply containing what's left of the yolk and the allantois, which are reduced in function to almost be functionless. You have a chorion, and the chorion is what develops into the implanted part of the placenta. So it's not for direct gas exchange anymore. Rather, gas exchange happens between the maternal blood and the fetal blood. And then you have a much larger amniotic cavity to cushion this embryo and prevent it from being affected by gravity. A much larger amniotic cavity is helpful because when you're restricted to the abdominal cavity in the uterus, you don't want to get that any kind of impact against the abdominal cavity to directly impact the fetus. So an enlarged amniotic cavity filled with fluid helps to provide a little bit of shock absorbance for that developing fetus. So pretty cool stuff. And now we're on to the primates, rapidly approaching the end of the mammals. So, the primates include the most successful and destructive of all mammals, good old hominidae. So, features of the primates. Primates have two features. They are not unique to primates, but them occurring together is unique to primates. First, we have grasping digits. So both the fingers and the toes have grasping digits. Nah. We do not have claws, rather, we have nails. The nails cover the sensitive fingers, they protect the fingertips. The fingertips have arguably some of the most rich sensory information in the primate. They can detect extremely fine touch, provides you with a lot of fine manipulation. Another important feature is the opposable thumb. So the first digit on each limb is an opposable thumb, right? So most primates have an opposable thumb on their hands and an opposable big toe on their feet. So the grasping digits, missing claws, having nails covering the sensitive fingertips with opposable thumbs to further increase your ability to manipulate objects. Uh, Cats actually have the not quite a digit, but a structure in their paw that is opposable. So cats can have a pretty good grasp with that opposable structure there. So not quite to the level of digit, but an opposable grasping feature is not unique to the primates. Primates also have binocular vision, which means their eyes face forward. Right? If you draw a horse, right, their eyes are okay. Their eyes are on the sides of their head. So this provides an impressive amount of vision. They have something like a 270-degree field of view, so they can see quite a bit around them so that they can monitor the world for predators. Eyes forward provides you with what we call stereoscopic vision. What that means is basically your field of view, each eye has a field of view, right? And when your eyes are both facing forward, there is an overlapping area in your field of view. And that overlapped area is our stereoscopic vision. That overlap provides superior depth perception. Organisms that have to chase down and eat something tend to have some degree of binocular vision. Right? So wolves have binocular vision, cats have binocular vision. A lot of different mammals have binocular vision for that superior depth perception. However, grasping digits and binocular vision is only present in primates. It is only the primates that have both of those. There are three main groups of living primates. The first group is some of the most basal primates, the lemurs, lorises, and bush babies. So these are, except for the lemurs, these are very small, nocturnal primates. Most of them are herbivorous or insectivorous. Uh, so they will eat small mammals opportunistically, but as you can see in this bush baby here, not exactly extremely well adapted to chase down and consume prey. The next group is the tarsiers. They are also a small nocturnal primate. Uh, they're fascinating because they have eyes that don't rotate in their head. So their eyes are so large, they fill the orbit so much that they literally cannot rotate the eyes in the orbit. So they have to move their head. So they kind of like have near owl like ability to rotate their head on their neck. They are primarily insectivorous and frugivorous. So they eat insects and fruits and various leafy greens, but primarily they have extremely long digits, which are good for reaching in to small cavities in order to get food. Tarsiers are pretty cute. They actually secrete a poison onto their fur. So they have little venom glands, and they will, with their little bitty hands, grab the venom and rub it on their fur. They also have relatively sharp front teeth. And so while they are cute, um, they're not exactly friendly. And if you see videos of them on the internet, uh, those tarsiers have been defanged. They've ripped the fangs out of their mouth, so they cannot poison anyone, and it's generally unpleasant. Also, most of those videos are shot in daylight, and if you look at their eyeballs, they are not daylight animals. So, maybe don't give those views so that they don't get their monetization from those videos, because there's pretty much the only way a tarsier can be kept in captivity in any kind of ethical way is in a zoo. Uh, so, finally, we have the anthropoid primates. This is what most people think of when you say primate, which includes the New World monkeys, the Old World monkeys, the great apes, and the hominids. So, New World monkeys is slang for South America. Old World monkeys is Europe and Africa. So then you have orangutans, which are genetically much more closely related to Old World monkeys than chimps and gorillas, which is fascinating. Then you got the gorillas, the chimpanzees, and bonobos are extremely closely related to the hominids. And finally, you have good old fashioned hominidae, which is a kind of like a pathogen to the planet. So that's kind of neat. Uh, anyway, so lemurs, lorises, and bush babies, the most basal of all the primates. Tarsiers are also a primitive primate. Then you have the New World, the Old World monkeys, the gibbons, orangutans, gorillas. So anthropoids diverged around 50 million years ago. So you can see right about here is where we got the divergence to get the anthropoids. New World monkeys is kind of odd because it's not like they're new animals. It's just uh, white Europeans hadn't seen them until they went to the New World. So, whatever. Eh, I don't know. It's dumb. Okay, let's talk about apes and hominids. The divergence of lineage between apes and hominids occurred about 20 million years ago. Uh, Hominids really developed their full on hominidae characteristics around 6.5 million years ago. So you find between 20 million years ago and 6.5 million years ago a variety of transitional animals. So, for instance, you have the Australopithecines, which had similar features to hominids, but also quite similar features to apes. So mostly transitional. Same with Ardipithecus, Kenyanthropus. These were mostly transitional forms. It wasn't until around 6.5 million years ago that you got full-on hominidae. So, features of the hominid. What makes a primate a hominid? First off, you are bipedal. You stand on two legs. So, in addition, so there's a variety of adaptations to being bipedal. One of the big adaptations to a bipedal life is the loss of the grasping big toe. Right? If you look at the big toe of like a chimp, it looks an awful lot like a hand. It's opposable, right? Because you are bipedal, instead of having a big toe off to the side like a great ape or like a chimp, the big toe ended up rotating forward. Right? So this is a hominid toe situation. This is because that toe has to be adapted for the way you walk, right? Your toes hit the ground when walking, and then the heel comes down. That big toe actually provides quite a bit of balance for a bipedal stance. So it's actually a really important adaptation to bipedal movement. In fact, Most of the things we'll talk about here are anatomical adaptations to bipedalism. So, in addition to the big toe, the spine of a hominid is altered, right? In a chimp, the spine, it has sort of an interesting little curve until it reaches the pelvis. In a hominid, because you have gravity pulling the skull and the body down, the spine developed a curve. And that curve is sort of like an arch to help distribute pressure. So your spinal curve allows you, so by the way, a spinal curve is a lordosis. That helps distribute vertical pressure. Oh man, I am running out of space. So, the spinal lordosis helps distribute vertical pressure, which is important. Having evolved from a spine adapted for quadrupeds, uh, it is not awesome. Spines give out depressingly common in hominids compared to their quadrupedal ancestors. So, there are specific adaptations in the spine to support bipedalism. The foramen magnum, uh, foramina are holes in the bones. Magnum means big. The foramen magnum is the big old hole in the skull where the spine and the spinal cord connects up to the skull. It is rotated in humans. So in a chimp and an ape, the foramen magnum is at the back of the skull because of their mostly quadrupedal stance. So here's their spine, whereas in a human, the foramen magnum is at the bottom of the skull. So, foramen magnum at the back of the skull to support where the spine connects up to the skull in a mostly quadrupedal animal. Foramen magnum at the bottom of the skull because that's where the spine connects up. And then we have specific anatomical adaptations to the pelvis. The pelvis has, compared to our great apes, it's generally larger, right? You have a larger pelvis. Uh, with larger joints to connect up. It's rotated to allow it to connect up to a vertically standing femur, right? So the pelvis is larger, it's rotated in comparison, and it helps to distribute the forces into your. So here's the spine connecting up to the pelvis, and we have our pelvis sort of rotated forward and the much larger joints to connect up to the femur. That is not an anatomical drawing of a femur. I know what a femur looks like. I am lazy. Okay, so those are all the specific anatomical adaptations for bipedalism that I am going to talk about. The next big feature of a hominid is tool use, right? So, tool use includes some basic stuff like manipulating fire in order to cook food, right? It can also involve making hunting tools in order to kill prey. And past that, you get into more complex tool use, making tools that allow you to make certain things easier. Potentially craft clothing, like sewing clothing together with sinew and needles. Uh, Making art, right? Art, artistic expression is something we see most commonly in hominids. So artistic and expression is a big one. Language. So both a complex vocal language and a complex written language. So we have a vocal language. This likely occurred first in hominids. It is much more complicated than most other vocal communication methods simply because we have a more complicated larynx, voice box. Most animals have a very simple larynx. Our larynx has the ability to make a large variety of different pitches. And then we have the echoing chambers of our mouth and nasal cavity. And then we have lips and a tongue, which can further modify the sounds that come out of our faces. So that allows us to have a complicated vocal language. And then later on in hominid development, we see complex written languages. And then, of course, we had that complex tool use, artistic expression, and symbolism, where we can use uh, symbols to express complicated ideas, right? So you have uh, various symbols. Ha ha, what's that? Anyway, everybody knows that symbol. Nobody really knows what it means. That's silly. But, you know, if you live in the States and you see a sign on the road that looks like this, you kind of know what to do because this shape is recognizable. We use this symbol to express the idea of stop. So, we are able to use symbolism to express complicated ideas. All right, here's the chart of hominid development. It's really cool just how many hominid species we have. Right? There's a ton of hominids. And there's a ton of hominids that closely resemble recent modern humans. If you're in the anthropology world, sometimes in a study you'll see RMH, and that means recent modern humans. So, we will compare skull morphologies and various bone morphologies to identify how closely related hominids are. And there are a surprising number of hominids that are very nearly close to recent modern humans. Here's Homo erectus. This one would have been difficult to tell the difference. We also have Homo neanderthalensis and Homo sapiens. And there's another one that I am forgetting because I'm always forgetting something. But that hominid is Asian. I think it migrated to Asia. So Neanderthalensis migrated into Eurasia, up in the mountains. Homo sapiens migrated out of Africa a little later on. And then there was a hominid species that migrated further into Asia than Homo neanderthalensis. But one thing that's cool to look at is the range, right? It is entirely possible that there were 3 to 4 hominid species on the planet interacting, right? Humans aren't the only game in town. There were 3 to 4 species of hominids on the planet expressing tool use, expressing, art, yeah, so very cool to think that at one point in time there were multiple species, and now there's just one. Recent modern humans, Homo sapiens. So lost that diversity, but what are you going to do? There's some evidence that Homo neanderthalensis had limited interbreeding with Homo sapiens, so at least some of their genes survive in the human population, primarily of European descent. So, man, I wish I remembered the name of that other hominid. I am going to look it up. Who doesn't love dead air while someone pursues uh, a random thing? So, la la la. Hominids, Homo erectus, Homo sapiens, oh, Homo ergaster. So that was another one. Lots of different. Homo heidelbergensis. Yeah, that was one. That's not on here. Homo heidelbergensis potentially was around during the time of Homo sapiens. So, at any rate, Homo florensis was an island Homo sapien that went extinct, but was modified to be very small by island biogeography. Anyway, that's about it for this lecture. See, we, us summer 2019 people, have already done ecology and the biosphere in lecture, which means we're done, folks. We're done. I am sad because no one asked questions. Sad face. Anyway, that's that. And hopefully this was educational at the very least. Maybe I entertained you a little when I got weird. Goodbye, one person watching this.